Hey, sixth grade, before we get started here, just a heads up, you probably want to have your screen in split screen. You have your Desmos Lesson 2, Unit 2, set up on one side, and then your PlayPosit on the other, so you can go back and forth. The other option is you can just go from window to window, flipping between the tabs. So we'll go ahead and make this full screen, get started for today. This table shows how many rolls of paper towels a store receives when they order different numbers of cases. What do you notice? What do you wonder? Go ahead and pause the video. What I want you to do is I want you to copy and paste this into your PlayPosit. What I'll be doing is you'll be getting a completion grade for today's PlayPosit. So I want you to just copy and paste what you have typed here and type that into your PlayPosit. Helium balloons can make objects float, but too many balloons will make objects fly away. Press the play button to watch the middle light balloon float. Why do you think this matters? Why do you think the number of balloons matters? Go ahead and share your thoughts here on PlayPosit. On the previous screens, we noticed that a light bulb weighed 2 ounces and needed 6 balloons to float. If each balloon carries the same weight, how many balloons do you need to float each object? So, 2 ounces needs 6 balloons. I'm looking for a multiplier from 2 to 6. How many balloons for 1 ounce? 3 balloons for 1 ounce. 2 times 3 is 6. There's my unit rate. There's my multiplier. So how many do I need for 10 ounces for the rubber ducky? You are correct. Hopefully, 10 times 3 is 30. Go ahead and try it. Now go ahead and fill in the rest of the table. Here are 2 strategies for determining the number of balloons needed to make the rubber duck float. How might Ariel and Emma use their strategies to finish the table? Go ahead and take a moment on PlayPosit, explain how both Ariel and Emma would finish their table. Here are some new objects, a cake and a banana. Complete the table so that each object floats. You'll see I didn't finish mine from before, but using what you know about the multiplier, finish the table. Remember before when I mentioned the word proportional relationships? Here it is. We are applying more academic, mathematical, algebraic understanding to what we know about equivalent relationships. When 2 quantities are always in an equivalent ratio, they have what's called a proportional relationships. Here are 2 more tables of balloons and weights. Which table represents a proportional relationship between weight and number of balloons? Go ahead and take a moment and just give it your best guess. You'll notice that table 2 shows a proportional relationship. The reason this is because a proportional relationship is always a multiplication or division relationship. When I go from 4 to 12, I'm not adding 8, I am multiplying by 3. 4 times 3 is 12, 6 times 3 is 18, 42 times 3 is 126, 8 times 3 is 24. From 3 to 6, 7 to 10, 9 to 12, I am adding 3. This is not a proportional relationship. A proportional relationship is one that always involves a multiplier, multiplication, or division. Go ahead and take a minute to write this here on PlayPosit. You don't have to write it on Desmos. How do you know this is a proportional relationship? Based on what we just talked about, we know that a proportional relationship can be represented on a table with either a multiplier or a divider. Go ahead and take a minute and sort these into categories. Oh, I should say something. A table shows a proportional relationship if they have the same multiplier. So I can multiply 1 times 10 is 10, 2 times 4 is 8, 3 times 2 is 6, 4 times 1 is 4. I can use multiplication, but they must be the same multiplier, just like when we looked at equivalent ratios. So this is not a proportional relationship. Go ahead and sort the other cards. How did you decide to sort this card? Go ahead and type, copy, and paste your explanation into the discussion here on PlayPosit. Finally, which of these relationships are proportional?